Okay. Equal vectors. You're required to know what an equal vector is, right? So equal vectors are vectors that have the same magnitude. So you see the length of that arrow, the length of the vector is the same direction. So you see the angle it makes with the x-axis, that angle is also the same. So same magnitude, so the length of the arrow is the same direction, the angle that the vector makes with the x-axis is the same. When I say direction as well, I mean the direction of the arrowhead, right? So let me just show you what I mean. Let's pretend that's a straight line. Let's say this is my vector, right? And it's going in this direction. The arrowhead says that it's going in that direction. This is my x-axis. Let's pretend that's a straight line. That's my x-axis, right? Let's say this angle between the vector and the x-axis, let's just say it's 25 degrees, right? That's just a random angle, 25 degrees. Hold on. Which top vector? Okay, yeah, right. So let's just say this angle is 25 degrees. The angle between the vector and the x-axis is 25 degrees. But then if I draw another vector, so it's still going like this. My x-axis is still here. Oh, bro. My x-axis is still here. And I tell you this angle is also 25 degrees. You might be tempted to say, oh, well, that's the same direction, same magnitude, both of these are equal vectors. But when I refer to direction, I don't just mean the angle it makes with the x-axis, right? I also mean the direction in which the arrowhead is pointing. So yes, these two angles could be the same. So 25 degrees, 25 degrees. The length or the magnitude of the vectors could be the same as well. Let's say it's 5 units, 5 units. But look at the arrowheads. One is pointing up. Well, not really up, but let's just say up. This one is pointing up and this one is pointing down. So these vectors, it's not the same direction. Even though it's the same angle with the x-axis, it's not the same direction. Do you understand that? Yes? No? Okay. We'll talk more about.
I understand.
Yeah, we'll talk more about that whole arrowhead thing just now, right? Like I have a whole PowerPoint, a whole note on it. Anyways, consider these two vectors. So A and B. See, I have them in bold because I am typing. Right, anyways. So let's say the column vector for vector A is x1, y1. For B is x2 and y2, right? Remember, x is always on the top, y is always below. So given vectors A, that's supposed to be an A. Anyways, given vectors A and B are equal vectors, so they told you these two vectors are equal vectors, meaning A is equal to B, then x1 has to be equal to x2 and y1 has to be equal to y2. Whenever you see equal vectors, it means that their components are the same. So whatever value I have here must be equal to the value here. Whatever value I have down here must be equal to this value. That's why we said A is equal to B. X1 has to be equal to X2 and Y1 would be equal to Y2. Do you understand that? Yes? No? Kind of? Repeat?
Yes,
so
ma'am,
far.
it looks very clear. Thank you.
Okay.
Very good, very nice.
All right. So example. We're sticking with the A and B, right? But in this case, the column vector for A is 7, 4. For B, it's 2x minus 1 and y plus 3. Do not panic. It's the same thing we're doing, right? If they told you that vectors A and B are equal vectors, and they want you to find x and y, right? So they told you these two are equal vectors. What does that mean? Their components are the same. So x1 has to be equal to x2 y1, let me use my laser pointer because like, yeah, y1 has to be equal to y2. That's just the definition of an equal vector, right? They has the same components. So x1 is equal to x2, y1 is equal to y2. So according to the rule, x1 is equal to x2. Therefore, 7, which will act as my x1, is equal to 2x minus 1, which would be x2. And from there, I could solve for x. Add 1 on both sides, so this will become 2x is equal to 8. Divide both sides by 2, x is equal to 4. Also, because in my definition of an equal vector, y1 has to be equal to y2. So in this case, my y1 would be 4. So y1 is 4. And then y2 would be y plus 3. And therefore, it's 4 is equal to y plus 3. Y would be equal to 1. How did I get 1? I subtracted 3 from both sides. Is that straightforward enough?
Yes, miss.
Yes, ma'am.
Okay, then, yes, it has been a while. So depressing. Right. So easy thing, right? Very, very easy. Just put one thing equal to the next and you're ready to go. Your turn. Find the values of x and y. Please. For number 1 and 2. Shouldn't take that long. It's just x1 is equal to x2. Find the value of x. y1 is equal to y2. Find the value of y. Very simple. Okay? I'll check you back in like 2 minutes.
Should we chat you the answer or through the chat?
Sure.
Okay.
Miss, may I do the same?
Of course. I have another Brandon in my class now. That's nice.
How is that? I don't know why these people are using my name. I'm the real one. I have no idea what's going on, but I'll roll with it. I'm not mad. I'm just confused.
Okay. And yeah, your answer is correct, by the way, for the first one. Good night, Brandon number 2. I have no idea who that is. Okay, wait. Anyways, I'm not even. Anyways. Come on, people, send me answers. I only got one answer so far. For the both of them, eh? Okay. So the first one, I mean, if you want me to write it out, it's okay. But I feel like it's very straightforward. The rule, when you're dealing with equal vectors, they have the same components. So x1 is equal to x2. So the x components are equal. Y1 is equal to Y2, so the Y components are equal. So what will you write for this question? They ask you to find the values of X and Y. They told you that Z and W are equal vectors. So what does that mean? 3 has to be equal to 2x minus 1. So the value you're supposed to get for X would be 2. 4 would be equal to Y plus 3. Then you transpose to make Y the subject of the formula, and you're going to get Y is equal to 1. Very straightforward. Anybody have any problems with that? If you do, it's fine, right?
No, miss, no problems with that question.
Wait, who's that? Yeah, 1.75 and minus 3.25, they're correct. And it's acceptable here to use the decimals because those are exact decimals, right? But if they weren't exact decimals, try to put the fractions. But in this case, it would be acceptable because they're exact fractions. Any exact fractions, exact decimals. I only have one answer for part 2. What happened to the rest of the people?
I think one went in general chat, but I think I sent you privately, so you should have at least 2 answers.
Oh yeah, I saw your answer. It's
Yeah, miss,
correct.
somebody sent our answer in the general chat.
Number 2.
Yes, miss, he sent our answer.
Who?
I don't know, boss. I think it's somebody named Papa Bear.
That was for number 1. Wait, that was for number 2. That was funny. But anyways, yeah, that's it.
Miss, good thing we got it correct.
Sleep deprivation. Don't do that to yourself. Okay, let me go through this one. Cause yeah, no, don't do that to me. I use the whiteboard because I don't think I can use the blackboard right now. Oh my gosh, this is so bright. Okay, yeah, this is very bright. If you have a problem with it, please let me know. Personally, it's just too bright for me. That's why I use the black screen, but
Excuse me, miss, the class is about to end.
oh, really? Okay. Okay, wait, I have some time. Oh, no, okay. Rejoin.